So in giant covalent structures, you need to know about diamond and graphite definitely. Sometimes you need to know about other allotropes as well. So diamond and graphite, they're allotropes. Allotropes are there are things that are made up of the same element. Okay, so like diamond is made up of carbon only, graphite is made up of carbon only. You've got fullerene that looks like a football, that is also a compound that is made up of carbon only, right? Yeah, diamond graphite, everybody needs to know. I'm sorry that if I skip a few things. I don't know who needs to know about fullerene and other allotropes, but diamond and graphite, everybody needs to know. Okay, so diamond, the structure is like you got one carbon bonded to four others. Okay, remember I said earlier on, carbon is capable of making up to 4 bonds. Okay, it has 4 electrons. It needs 4 more to become stable, because 8 electrons get used stable, right? So right, so I'll just use lines. Okay, so each carbon is bonded to 4 others. Obviously you can't draw the whole structure because it's going to be like never ending. Okay, it's horrible now. Well, I believe up to 3 layers, or like 1 2 3 4, like, you know, up to that is fine. I don't know why I'm going extra, but you get the idea. All right, so carbon, so diamond is a tetrahedral structure. Tetrahedral structure. There's another compound, I think silicon oxide, SiO2, I think, yeah, silicon oxide, or sorry, silicon dioxide, that also it is also a giant covalent structure, and it also forms a like, you know, it has the same structure as diamond, like it's tetrahedral. Okay, so okay, yep, so we got tetrahedral structure. Each carbon, so each carbon is bonded to 4 others. Okay, so yeah, they're all stable. So they're all stable, and then have a high melting point. You know, anything, if it has a high melting point, it will also have a high boiling point, because you got to melt before you boil, right? Sorry, not you, but you get the idea. Yeah. So properties, it has a high melting point, high boiling point, and because, okay, now they always ask you this, not always, but most of the time they ask you this: why does it have a high melting point, high boiling point? Because it's a giant covalent structure. There are many strong covalent bonds that need to be broken. Okay, so it's a giant covalent structure. There are many strong covalent bonds. What was the third one? There also used to be 3 points I used to talk about. Yeah, so a lot of energy, a lot of energy is required to break those strong covalent bonds. Right, so yeah, why does it have a high melting point? Because it's a giant covalent structure. There are many strong covalent bonds. A lot of energy is required to break, you know, so many covalent bonds, right? That's about it. I used to think there was more. I'm pretty sure I used to have more rows here. Can't think of that now, but these are the key things you need to know. And oh yeah, they do not conduct. So diamond does not conduct electricity. Okay, where should I write that? Maybe above here. So no electricity. conducted. Okay, because there's no charge that is free to move around, so diamond does not conduct electricity, right? So overall, it forms a tetrahedral structure. Okay, each carbon is bonded to 4 others. Now we didn't really expand, on here. Like, I mean, this one you see it's bonded to 1. It's not bonded to 1, but we're just we chose to just draw a small part of the structure. Okay, so to make it to simplify it, we must we can't realistically just keep adding. It becomes messy. It's hard to see. So we start with 1 and then we keep expanding to show what we mean. Right, so each carbon is bonded to 4 others. If it's not clear, let me show you. So this, look at this carbon. It's bonded to this one, this one, this one, this one. So it has 4 bonds, right? So each carbon is bonded to 4 other carbon atoms. Do not write this at this, please be more detailed. So each carbon is bonded to each carbon atom is bonded to 4 other carbon atoms. If you want to be nice, say covalently bonded to 4 other carbon atoms. Okay, right. So they have a high melting point, high boiling point, because giant covalent structure. There are many strong covalent bonds. A lot of energy is required to break those strong covalent bonds. Okay, I've done graphite. I know I'm repeating a lot, so let's move on to graphite. So graphite is like hexagons. I strongly recommend to draw 3 layers at least. So that was 1 layer. Okay, so at least 4 hexagons in each layer. Okay, and draw 3 layers at least minimum. Right, then you draw those dotted lines because they're not separated. It's part of the structure. Okay, now if you focus on one, let's say this, each corner is a carbon atom. Okay, so look at this one. This is bonded to 1, 2, 3 carbon atoms. Okay, so that means in graphite, each carbon atom is covalently bonded to 3 other carbon atoms. So it has 4 electrons, right? So if 3 of them are busy with 3 covalent bonds and getting involved in 3 covalent bonds, there's a 4th one that will not be busy. So that is the one that is actually delocalized around the structure. Okay, so it's delocalized around the structure, and because there is charge that is free to move around now, so this charge is that delocalized electrons. So graphite conducts electricity. So this conducts electricity, this didn't. Okay, so and that's because each carbon atom is covalently bonded to 3 other carbon atoms, and that's why we have a 4th electron from each carbon atom that is delocalized in the structure, that is freely moving around, and that's the reason why graphite conducts electricity. And I just remember one thing. So graphite is slippery because the layers can slide over each other, because when you write with pencil, it's made up of graphite, you're able to write because each layer is like sliding away. Okay, and there are weak again we have weak van der Waals forces, between each layer. Okay, so the covalent bonds are strong, and that's why this whole thing applies here as well. Okay, So it is a giant covalent structure. There are many strong covalent bonds. A lot of energy is required to break those covalent bonds, okay? But between each layer, there's no covalent bond. This is not a covalent bond. The dotted lines are not covalent bonds. So between each layer, you have weak van der Waals forces of attraction. And that's why, with a bit of energy, they slide over each other. So that's why it's slippery, okay? And that reminded me, I forgot to say something, that diamond is hard. You need to remember this. Because each carbon atom is bonded to 4 others, it's forming a tetrahedral structure. And that's why it's hard. And diamond is one of the hardest known materials on Earth, okay? And yeah. So I've done the properties, the high melting point. It's the same reasoning for both of them. You must remember the differences between between diamond and graphite. So it's in diamond, it's each carbon is bonded to 4 other carbon atoms, and in graphite, each carbon atom is covalently bonded to 3 other carbon atoms. Okay, and the fourth one is the fourth electron from each carbon atom is freely delocalized around the structure, so it conducts electricity. And in diamond, there's no charge, there's no electrons that are free to move around, so it does not conduct electricity. Right, and graphite is in layers, diamond is a tetrahedral structure. I think I've said everything you needed to know about diamond and graphite, and yeah, that's about it. I hope you do well in the exams. Any question, please message me. Okay, right.